In section 5.1, part A, we will talk about quadratic functions. Now, if you recall, the graph of a quadratic function is in the shape of a parabola. If the a value is greater than 0, the parabola opens towards positive infinity. If the a value is less than 0, the parabola opens towards negative infinity. The vertex of the parabola we will refer to as a point h comma k. The vertex we will refer to as a point h comma k. And the vertex form of a parabola is given by y equals to a times the quantity x minus 8 squared plus k, where the vertex is the point h comma k. Now these steps we will go over in the upcoming examples. So example 1, in the equation, write the equation of vertex form of the quadratic graph below. So let's take a look at our steps. Step 1, we identify the vertex hk and replace the h and k values in the equation y equals to a times x minus 8 squared plus k. So let's go ahead and do that. Our vertex is this point right there, and that point is 3 comma negative 4. Okay, so our vertex has a coordinates 3 comma negative 4. The equation of a parabola in vertex form is this. So we're going to say y equals to a, which we don't know what that is, times x minus h. The h value is 3, so this is the h value, that's the k value, x minus 3 squared, plus k, which is plus negative 4, which means we can just write that as minus 4. But we still have to identify the a value. We have to find out what that is. So step 2, identify a point on the graph identify a point on the graph, the point is xy, and replace the x and the y values. So on this graph, let's identify a point. Now the point, it can't be something that we're going to approximate. It has to be a point that we know its exact location. So let's take this point for example. This point is a point 1, 2, 3, 4, 5, comma, negative 2. Okay, so our point is the point 5, negative 2. I could have taken any point on the parabola, like I could have taken this point, for example, as long as it's an exact point and not an approximation. But what I mean by that is like here, for example, you're kind of approximating. Is it halfway between? Is it 3/4 of the way between? We don't know. So we got to pick a point that's an exact point. And no matter what you pick, you will always get the same a value. So since I picked my point as 5 comma negative 2, I'm going to replace the y value with negative 2. The a value is unknown. I'm going to replace the x value with 5 and leave everything else the same. Now my objective is to solve for the a value. So I'm going to simplify this using the order of operations. I have negative 2 equals to a times 5 minus 3, which is 2 squared, minus 4. So 2 squared we know is 4. So that's going to be 4a minus 4. This becomes an equation which we can solve. So if I add 4 to both sides, I'm going to get 2 equals to 4a. And if I divide everything by 4, I end up with a equals to 1/2. Now I'm going to show you guys the same thing with a different x and y value. Okay, so instead of picking this point 5, negative 2, what if I pick this point, which is a point 1, 2, 3, 4, 5, 6, 7, comma 1, 2, 3, 4. So let's say instead of 5, negative 2, I pick the point 7, comma 4. Let's see if that would make a difference. So my equation is y equals to a times x minus 3 squared minus 4. That's my equation just with the vertex plugged in. Okay, so let's plug in the point, this one right here, which is the point 7, comma 4. So I replace the y value with the 4, and I replace the x value with the 7. Okay, so I have 4 equals to a times 7 minus 3 is 4, so that's going to be 4 squared minus 4. 4 squared is 16, so this is going to be 16a minus 4. To solve this, I add 4 to both sides. That gives you 8 equals to 16a. Divide both sides by 16, and 8 over 16 is 1/2, so this gives me a is equal to 1/2. So the generic equation is going to be the equation y equals to a, which is 1/2, times x minus 3 squared minus 4. Okay, the second example, let's save this one for class. Next example is the same thing, except instead of a graph, we're actually given the vertex and we're given a point. So let's go through our 3 steps. Step 1, identify the vertex, which we know is the point. So the vertex is negative 4, 1, which means the h value is negative 4, k value is positive 1, and we're going to replace it in the equation that's in the vertex form. So we're going to have y equals to a, that's unknown, times x minus h. So h is negative 4, which means I'm going to get x minus negative 4 squared plus k, which is going to be plus 1. And when we got the two negatives, we got the negative negative 4. That becomes a positive 4, as we know. Okay, so our equation is going to be y equals to x plus 4 squared plus 1. Okay, so that's x minus h, which is x minus negative 4 squared plus 1. Now let's take a look at a point that's on the graph. Let's take a look at the point negative 1, negative 17. So y gets replaced by negative 17, x gets replaced by negative 1. Oh, and I forgot the a in the front, plus 1. So I have negative 17 equals to a times 3 squared plus 1. So I have negative 17. 3 squared is 9. That's going to be 9a plus 1. To solve this equation, I'm simply going to subtract 1 from both sides. That gives me negative 18 equals to 9a. And I divide everything by 9. So a is going to be equal to negative 2. So my equation is going to be y equals to a, which is negative 2, times the quantity x plus 4 squared plus 1. Next example is similar, but we will save this one for class. Now remember that if you have a quadratic function in the form of f of x equals to ax squared plus bx plus c, the vertex is going to be the point h comma k. So if this is your parabola, the vertex we write as a point h comma k. If the equation is in vertex form like this, we can say our vertex is negative 4, 1. Okay, that's easy to determine. But what if it's not in the vertex form? What if it's in the form of ax squared plus bx plus c? Then here's how you find the vertex. The x coordinate of the vertex is given by the formula h equals to negative b over 2a, where a, b, and c are these coefficients. And the y coordinate is when you take the negative b over 2a, whatever that value is, so the h value, and you plug it in, you'll get the y value. Okay, so let's go ahead and take a look at an example. Find the vertex, the x-intercept and y-intercept of x squared minus 6x plus 8. So when we have the format ax squared plus bx plus c, the coordinate is going to be the point h equals to negative b over 2a. So first let's identify our a, b, and c. So our a value is a coefficient of x squared, which means our a value is 1. The b value is a coefficient of the x, which is negative 6. And the c value is a constant, which is positive 8. And so the x coordinate of the vertex is h equals to negative b, which is negative negative 6, divided by 2 times a, which is 2 times 1. So this gives us 6 divided by 2, which is 3. That is the h or the x coordinate of the vertex. To get the y coordinate or the k value, remember k we refer to as a y coordinate of the vertex, we simply take the h coordinate, which is 3, and we replace each x with a 3. So k is going to be f of 3, which is going to be 3 squared minus 6 times 3 plus 8. So this is 9 minus 18 plus 8. 9 minus 18 is negative 9. And negative 9 plus 8 is negative 1. So our vertex has an x value of 3 and a y value of negative 1. And anytime you want to find the vertex, you always use this formula, negative b over 2a for the h value. Whatever the h value is, plug it in order to get the y value. So our vertex is 3 comma negative 1. For the x-intercepts, now remember the x-intercepts, these are the points where the graph is going to cross the x-axis. And at the x-axis, the y value is always going to be 0. So to find the x-intercept, set the f of x or the y value, this entire left-hand side, equal to 0 and solve for x. So our equation is f of x equals to x squared minus 6x plus 8. And we are going to replace the f of x or the y value with 0, so we get 0 equals to x squared minus 6x plus 8. Now there are two ways to solve this. You can either factor it or use a quadratic formula. If it's factorable, it's always easier to use factoring. So I'm going to find two numbers which multiply to be 8, add up to be negative 6. And those two numbers are going to be negative 4 and negative 2. They multiply to positive 8, they add up to be negative 6. So from the zero product property, if I solve x minus 4 equal to 0, I get x equals to 4. And if I solve x minus 2 equal to 0, I get x equals to positive 2. So my x-intercepts are 4, 0 and 2, 0. And remember that for the x-intercepts, it's always going to be the x value, 0, because we set the y value equal to 0 in order to find our x-intercepts. Now, to get the y-intercept, it's the exact opposite. We are going to set the x value equal to 0 and solve for y. So we're going to say that f of 0 equals to x squared, which is 0 squared, minus 6 times 0 plus 8. So that's going to be 0 minus 6 times 0, which is 0, plus 8, which is going to be 8. So our y-intercept is the point 0, 8. So just to clarify, to find the x-intercept, set the y value equal to 0 and solve for x. To find the y-intercept, set the x values equal to 0 and solve for y. And for the vertex, negative b over 2a for the h value, and plug that in to get the y value. Okay, so this next example, please try by yourselves, or we can do it in class. Next example, we are going to apply the quadratic formula. So the quadratic formula is here. We've done this before. So the a value is negative 6, the b value is negative 7, and the c value is negative 2. So let's go ahead and plug this into the quadratic formula. So we get x equals to negative b, which is negative 7, plus or minus the square root of b squared, which is negative 7 squared, minus 4 times a times c, and then that's divided by 2 times a, which is 2 times negative 6. So we have two negatives back to back, negative 7. We know that becomes a positive 7. Then we got plus or minus square root of negative 7 squared, which is 49. Minus, so here we got to go left to right and do it two at a time. Negative 4 times negative 6, that's a 48. And then, or sorry, negative 4 times negative 6, that's a 24. And 24 times negative 2 is negative 48. So once again, this part, make sure you just go left to right, two at a time. Negative 4 times negative 6 is 24, and 24 times negative 2 is negative 48. So this whole thing becomes a negative 48, and then all of that is going to be divided by negative 12. So if we continue on with this, we're going to get 7 plus or minus square root of 1. 49 minus 48 is 1, divided by negative 12. We know that radical 1 is 1, so this gives us 7 plus 1 over negative 12, and 7 minus 1 over negative 12. We split this up into two separate expressions, one for the plus, one for the minus. So 7 plus 1, that's going to be 8 over negative 12, and 7 minus 1, that's going to be 6 over negative 12. And if we take 8 over negative 12 and we divide these both by 4, so we reduce it, this gives us a negative 2/3. The negative just moves to the middle. If we take 6 over negative 12 and we divide these each by 6, this gives you a negative 1/2. So our solution set are the points negative 2/3 and negative 1/2. And then this example we will go over in class. This next example we will also go over in class. And that's it for the lecture.